Hello, welcome once again. A tutorial about, again, the important issues of fuel injectors, fuel pumps, and the computer itself. I was asked which books I use and the title of the books. Like I was saying, these specific books that I use are from the dealership itself. This is the title of it. See? Service Manual for 2003 and up. There are 3 books of these. See how thick they are? Literally 800 pages. There's another one over here, another one, 800 pages, and there's a third one, over $200. Depending on the year and the make and the model that you go through. But basically, they're all the same idea. So anyway, those are the books, and these are the best of the best. But however, they are expensive, and you really have to know your stuff to interpret these things. Like you see. Like we're going to go over in this example, like you'll see in this example, you have to know what the computer is doing. And it's pretty complicated, these type of books. But anyway, excuse me, now we're going to get to the fuel pump. Now we went over several fuel pumps. Like you said before, one issue is where it gives it a ground. Other issue is where it gives it a 12 volts. In this example over here, when we look at it, first thing that gets your attention is the powertrain control module. This computer over here gives the 12 volts over here to this. How do I know this is 12 volts? And how do I know? Because this side over here goes to the ground, the physical ground. This side over here, excuse me, this side over here goes to the powertrain control module, which is the main computer. It would only be fitting that it would give it 12 volts internally. All these switches and resistors are internal, so it's fitting that it would give it a 12 volts on this side. So once it gives it a 12 volts, current flows from here. This is closed now. The switch is closed internally in the computer. You can't see it. And you can't find this switch. Whatever is in there. Could be transistors, whatever is in there. But it's not really a concern. As long as it gives us 12 volts at this point. So C2 over here. And then the connector C2. You see this C2? What color it is? Connector ID. That means the C2 is a black one. If you're looking for C1... this one, C1, you're looking for a blue one. So, this information, the color of the connectors, I haven't found in other schematics except the dealership, which I'm showing you right now. You see the connector ID? It gives you the connectors over here. And it shows you the colors of them. So that's pretty impressive that it gives you that information. But they have to. It's a dealership, so they give you every possible thing. So anyway, so current flows here, goes here to ground, to a black wire to ground. Now the other side is just normal, hot at all times. That means if you put even the run position, you should get the fuel pump running. So if as long as this is energized, this will close. Now current flows from here through a fuse, a 20 amp fuse. What's the title of the fuse, or identification I should say? UCMB. UCMB goes here, goes to the fuel pump, starts the fuel pump going. And as you can see, 2 different grounds over here. Now, that's fine for fuel pump. As I said before, I wanted to thank the comment. I forgot the person's name. The comment. I was going through a starter motor. Actually, right, an ignition schematic for the ignition and a starter motor. There was a part that I did leave out in the schematic on the bottom, which goes to a ground. Either the computer could give it a ground, or there's a physical ground. A physical ground meaning this. G1 or 2, it's a physical ground, a body ground, a chassis ground, or the computer can give it a ground. I left out that part, so I want to thank that the viewer for giving that comment. So when I get a chance, I'll go over that. But thank you for this advice. So anyway, this doesn't give it a ground, this gives it a 12 volts. Where's the best point to go? Again, I think you know how I operate and my thinking. Where's the best point to go to see where there is, if everything works? I always go over here, as you know me. There was a connector at a time the way you can actually go over here and see if there's 12 volts. See this fuel pump pipe connector? There was such a time, or these types of models, to go here and to measure 12 volts. And that will tell me this is working, and this is working, and this is working, and I have a ground, a complete ground path. That's why I put fuel pump connector over here. So remember, if you have 12 volts over here, doesn't necessarily mean you have 12 volts over here, because what happens if this fuse is open or this wire going to the fuse is broken? So first go here, then go over here. Then over here, how much should you get? If you have 12 volts over here, the whole voltage drop is across this, and you should get 0 volts because this goes to ground. Now, the reason I did this, and I did so many of these, is I wanted to show you, in this one over here, you see this is a ground. This is the instrument cluster. The instrument cluster is where it tells you the dashboard. It gives you all the information of all the gauges and the check engine light right in front of the instrument panel. That's the one that has all the lights. So as you can see over here, this is a ground going to the instrument panel from this. This is a ground, a low reference, also a ground. This looks like it's a 12 volt or a 5 volt line, because this is a resistor. It looks like it's usually went to 12 volts, but now it's going to like 5 volts. It's dropping a voltage across it, and it's giving this voltage to this instrument cluster to turn it on from this PCM board. So it's a little tricky. That's why I say these dealership schematics are very, very, very complicated. Unless you really have to know your stuff, what's going on here. They don't explain everything, because they do expect the technicians to understand things without explaining every little thing in the diagram. That's why I'm saying, for beginners, I do not recommend something like this, because if you look at this, if you're a beginner, you would say, what's this and what's this? But that's what I'm saying, is usually for the technicians over there. So anyway, sometimes even the technicians themselves have problems trying to figure these things out. It's a little high level of electronics, these type of schematics. But anyway, like I said, ground here, a ground here, and some voltage over here. Could be probably 5 volts, like I'm saying, over here, to start the instrument panel, which is on the dashboard, obviously. So anyway, so that's how that works. Now the fuel injectors himself. Wanted to point out, look at the ratings of these fuses for the fuel pump, since it is a fuel pump, and the load side always goes to the load. This is the load, the fuel pump. 20 amps is the fuel, as you can see, is the fuel pump. But over here, as you look at this, fuel pump relay, fuel pump relay, fuel pump relay, fuel pump relay. Look at this. What's missing? There is no fuse here. The fuse is only on the load side, right? Let's say you have a short over here. What do I mean by a short? Let's say I have a dead short from 12 volts to here. What would take it? What would protect it? Interesting, no? I don't see no fuse, unless I miss something, right? Only fuse is to protect the fuel pump. But anyway, this has a fuse for the fuel injectors. How many cylinders are there? 1, 2, 3, 4, 4 cylinders, 4 fuel injectors. So we come over here. This is called ECM 1. Now, what I wanted to show you, the point of this video was, you can't always go by the identification of the fuse as what it's connected to. In other words, this is connected to fuel injectors. When I look at ECM, you know what ECM means? That's the computer board, the computer module. When I go over here, ECM B, but look what it's going to, the fuel pump. Why isn't it called fuel pump fuse? So when you look at the cover of the fuse panel and you look by the identification of the fuses, it'll be misleading to you. You won't be able to figure it out which fuse is going to the fuel pump. So that's what I'm saying. The best thing to always get the schematic so you won't be lost or make mistakes. So now ECM1 over here, fuse over here, current flowing to each one, and they all go to a ground. However, again, the PCM plays a role. It gives it a ground. You see these grounds over here? It gives it a ground to turn it on and off, on and off, on and off. Based upon the air-fuel ratio, based upon the oxygen sensor, comes out the exhaust. Many oxygen sensors, bank 1, bank 2, if it's a V6. It has to adjust the fuel trim, they call it, according to the air-fuel ratio. It tries to get close as possible to 14.7 parts air to 1 part fuel. That's the recommended ratio to give you the proper emissions, basically. Not to get too technical, however, I just wanted to point it out to you. The computer plays a main role for the fuel injectors, for the fuel pump. If the fuel pump is not on, you can blame the computer. If the fuel injectors are not on, let's say I have fuel pressure because the fuel pump is working. Well, to point this out. But when I go to the fuel injectors, number one, they're hard to get to in this type of make and model DGMs, because for the simple reason, because they are buried down by the intake manifold. You have to take everything out. These spider puppet nozzle that they have, a fuel ejection system. They're very hard to get to. Very hard to get to these fuel injectors. So I would go to the fuse over here. And where you want to see the signal is over here at the ground to see make sure they're toggling. But you'll get 12 volts over here, as you can see. But what happens if this fuse is open? Guess what happens? I'll have fuel pressure. Shouldn't I have fuel pressure? The pump is going, but there's no fuel injection over here. I'm not pulsating these fuel injectors on and off. And when you don't see all of them, you go for the fuse. So anyway, I hope this was helpful. And like I was saying, we always have to take into consideration the computer is the boss. He's the one who controls starter motor, fuel pumps, as you are witnessing right now. Anyway, please go to my channel, Automotive Electronic Schematics by Joseph. My other channel, I'm trying to get some views. Views are low on this one. Thank you for the support for the other one that I got monetized. Incredible achievement for me it was. But anyway, I'm working on this one. And see modules and videos that I work hands-on. How to measure mass airflow sensor, how to go inside, how to measure in-circuit relays. Not taking relays out. You'll see those videos, how I measure them. And I go to this point over here. And many people say, how can I measure the relay? I have to take the relay out. How can I measure it? Well, in that video, it'll show you how. You take it out, put a piece of wire, and you put the relay on top of it, making sure it makes contact all the way down. You'll see exactly, if you go to those videos, you'll see exactly what I'm referring to. That's why I'm going over this again. Those videos do not have that much views like I thought, and that's why I'm trying to recommend those videos so you'll understand better. If you understand this, you'll understand what I'm doing in the video. Thanks for watching.